Hey guys, Mr. Krenz here. I'll be back on Wednesday. I'll be at a workshop or conference on Monday and Tuesday. In the meantime, I'm going to get you guys started on your very first research project of the year. Okay? The whole purpose of learning statistics is so that if we're given a data set that reflects something about the real world, we can actually start to determine whether it actually means anything, whether there's anything interesting happening or not. Okay? In Chapter 1, you guys learned about one variable relationships. You looked at distributions. You learned how to describe distributions. And we also learned how to summarize one variable data with some statistics, namely the IQR, the mean, the median, the range, and so on. All right, two main things we're measuring there are centrality and also the variation in it. Right. Chapter 2 we expanded. We started talking a little bit more about location in a distribution, and we also talked about the normal distribution, a very, very specific and useful distribution that tends to come up a lot in the real world. Chapter 3 we expand our knowledge to two variable relationships. Our main graphical tool in that was the scatter plot to see if there's a relationship between two variables. And our main statistical tools were linear regressions, and then R and R squared. Chapter 4, we started looking at where the data was coming from. In the first three chapters, we were given data. We did a whole bunch of things with them, but we had never been asking, like, where is this data coming from? Is it good data? What are some potential problems? The main three types of things we looked at were either observational studies, experiments, and surveys, and we identified a lot of potential problems that can commonly come up if you're not very careful. Using all of those four chapters of knowledge, everything you learned about statistics, we can actually make a very good start on performing statistical analyses and learning more about the world that's around us. In this project, I want you guys to pick something that's really actually interesting to you. And I really, really mean that. It makes it far more interesting for me to read, and it makes it much, much, much more enjoyable on your part to actually perform the statistical analysis if you actually care about the results. If you pick something you care less about, it's just going to be painful the whole time. Word of warning, one of the most difficult parts of any research can be finding really good data. We won't be actually collecting our own, we're just going to be looking online for data sets that we can answer our questions with. I'm anticipating this probably one of the most challenging parts of the project will be finding that good data set. I'm going to give you guys a few ideas. There's a lot of really good resources, like if you're going to sports, ESPN's got a ton there. There's really great census data that you can access online through the U.S. Census website, and there are a number of other data sources. You guys are good digital citizens. You can also search the internet and find your own. But it may take quite a while to get a good data set and to get it all cleaned up. When I say cleaned up, I mean getting in a format that we can actually use, which most time will be in a spreadsheet that's actually organized, that doesn't have missing values or kind of weird cells. That's going to take a while, and anticipate that. Don't get too frustrated there. Once you have your data, I have you guys performing an appropriate analysis. I'm not going to say specifically what that has to be, because that could very well change based on the question that you ask and the data that you find to answer that question with. Once you're done with your statistical analysis, I'm going to have you communicating this to the rest of the class and to me with a research paper. All right. You do not need to put every detail of how you performed every step of your analysis in the paper. So you don't, if you're calculating z-scores for something, you don't need to show me how you calculated the z-score. You do not need to describe how you created the graphs using a spreadsheet or how you created them using Plotly, but I do want you to paste in the results there. So when I read this paper, you kind of introduce, like, here's the idea, here's why it's interesting, here's the context of it. Tell me something about the data, how is it collected, is it good data, are there potential problems with it, and then give me the results of your statistical analysis and interpret them for me. Like any good paper, you're going to conclude at the end, reflect on it, say whether you answered the question or not. Maybe you'll even ask an extension question, which would be interesting for a further study. All right. If you guys have questions about this, please tweet or email, as always. I'm pretty sure we're going to have pretty good internet access throughout the conference, so I think that if you tweet or email, I'll be able to get back to you relatively quickly, but I can't promise you anything. At worst, if you email or tweet tomorrow, I'll definitely get back to you at the end of the day so that the next day can be more productive. I do not expect that you guys necessarily finish this by Wednesday, but you will not get a whole lot more time, if any time, after these next 2 days. So you want to get a lot of your work done soon. I'll start class on Wednesday by taking some questions you guys have about the project and the specifics here. But good luck. Have fun with it. Really think about the question you want to ask. Make it something you really care about, something that you don't know already. And it's going to make this project hopefully a lot of fun. I enjoy working with students when they actually get to work with their interests and bring those up. And sometimes there can be really, really fascinating things that come out of this. So, see you guys on Wednesday. Let me know if you have any questions.